everyone. Welcome to Superna's first integrations webinar of 2026. I hope everyone is having a great start to their year. My name is Lauren Johnson, and I'm Superna's event coordinator. And I'm now going to pass the mic over to Superna's Chief Technology and Strategy Officer, Andrew MacKay, and he will walk us through today's presentation.
Thanks everyone for joining. We're here to talk about incident response. And so, we talk about cyber incidents, we talk about data a lot, and we've had a real focus over the last several years around incident response. And incident response is powered by integrations with security tools. So we're going to talk about incident response. We're going to talk about our approach to integrations, how we view cyber incidents and the life cycle, and some of the challenges, and then what the future is going to look like. Of course, it has to have AI involved. So like everything else, we're being inundated by AI stuff left, right, and center. But this is a cool use of AI, and it's available off the shelf. I like to use this slide. I use this slide in a lot of presentations. The state of the cyber data protection world as we know it, $200+ billion spent annually on cybersecurity tools. That's an enormous amount of money. And that number goes up year after year. Except we read about the frequency of breaches is increasing, and the news is littered with compromised companies left, right, and center, data exfiltration, cyber incidents. Ransomware, of course, is right there at the top of the list. It's getting worse, not better. And it seems so obvious, but what is the singular target of every cyber breach? It's always some form of your data. It's without exception. They're not, the days of Bitcoin mining attacks where they're borrowing your CPU are gone. It's all about your data. That's always the target. We think that this $200 billion, so, what's the root cause here? Well, we have the most spent on cyber resilience and the worst outcomes in the history of IT. It's not very good, right? So I give the industry an F, an absolute F. And if the target is data, then maybe we should think about diverting some of this $200+ billion at protecting data and treat data as the attack surface. And if you did that, would you come up with a different solution to what we have today? So we think the answer to that is yes. And we're going to throw a few poll questions out kind of every few minutes. This is things we want to learn about our customer environments. The more we understand, the better we can build technology and tools to help you. So we'll drip feed those out as we go. The biggest gap in incident response, and when I say incident response, that's your SOC team and your tools and technology. So we're going to talk about a SIM for event collection, a SOAR, although the SOAR, the standalone product category, is kind of disappearing. We see that merging. But we talk about, you get an incident and then you take actions, and those actions are to remediate, quarantine, and recover if necessary. So storage is, if it's the target of the attack, and yet traditional IR is like endpoint focused, network focused, and all the actions in your security tools are all aimed at taking actions against endpoints and users, but no data actions. So that's one gap. And so as I mentioned, if you look at all the breaches that make the news, what is one thing that is true in all the breaches, all the companies that unfortunately had to go through that awful incident? Did they all have endpoint software? Of course they did. Did they all have SIM and SOAR technology? Of course they did. Did they have an incident response process? Of course they did. And yet the record breaches of data, right? So clearly the approach that we have been using isn't good enough to lower the breach rate and protect your data. So we think this gap needs to be closed. And again, we talked about identities and access management, network perimeter. It's the perimeter where the focus is never on the data and who's accessing it, who's using that data, what behaviors can we look at of data access. If there is access to data, is that pattern okay or is it not okay? So if we looked at the problem statement and we combined endpoint, network, identities, and storage as a singular way to view the problem statement. And if we can combine these and have them all work together, and we can leverage integrations so that we can, like a practical example, We can see an attacker doing something bad to data. Could we ask the endpoint software to isolate the host? We can do that through integrations. If I see an identity that is logged in 16 times to the storage and I flag that to the incident response tools, yes, we can. These are all things that require integrations to integrate the storage security awareness with the endpoint, the network, the identity management system, and get it in front of the incident response team. And that, of course, is SIEM, SOAR, or your ITSM environment. So we need to move from an edge security paradigm to a data first security paradigm where we leverage the existing investments you have in endpoints, network, and identity, and we make them all work together. Why is storage well positioned to be a key component of your data defense strategy? Well, it sees users, it understands usernames. Your storage knows who's logged in. It also knows where they're logged in from. It knows their IP address. It has the ability to create snapshots. And for everyone that isn't a storage administrator, snapshots give you a quick, near instantaneous, immutable copy of your data that you can leverage for recovery if you needed it. They effectively have a zero cost. They grow as data changes, but essentially the time to create a snapshot on a petabyte file system is sub-second. If you're monitoring the storage, can you understand permissions? Yes, we can understand that this user has access to a lot of data. This user has access to a little bit of data. So we can predict the blast radius. If I can predict the blast radius, I can quarantine files and protect data. So storage itself has a lot of built-in capabilities that just aren't leveraged. Our solution, our software is active defense for your storage, but unless you can see it, you can't protect it. And that's where integrations come in. So integrate with what? Well, which of the security subsystems? So we got SIEM, event logging, we've got SOAR, orchestration, automation, we've got endpoint, we've got identity and access control, and then vulnerability management tools. All of these tools are unaware of what happens at the data layer. So what would happen if we unified the discovery of data threats and automated enforcement, so blocking users' access to data, and automated the recovery? What if we put all of this into a control plane and integrated it back into your existing tools? What would that look like? Well, it would look like this. We offer over 60 plus integrations with over 30 vendors. This is a very small subset of the vendors that we work with. But the idea is that if we can identify a threat at the data layer, and so what is data? It's files and objects. I don't want to forget object security. We talk about files a lot, but these days, object is first choice for applications. It's no longer the place where your backup data lives. It is a production real-time, flash-powered storage platform. So any security story you invest in needs to handle files, that needs to handle object. We're uniquely positioned here because we offer file and object with Dell PowerScale, and Dell Object Scale. I keep wanting to call it ECS, but we integrate with both so we can give you complete visibility of what's happening to your files and your objects. We, of course, offer the market-leading cyber storage solution, and I call it cyber storage because that's the name that Gartner gave it. But basically, we can detect anomalies at the data layer, file or object. We can identify the attacker. We can stop the attack. We can record the transactions of what happened. We can snapshot or versioning in the case of an object. And we can fully automate the recovery of data without requiring backup restore software. And it's precision-based, meaning we know what data was touched, so we can be precision-oriented in that recovery. Why does that matter? If we can recover faster, we can get your business up and operational quicker, and we can minimize downtime related to a cyber incident. We have SIEM and we have SOAR. So it's imperative that all this cool security at the data layer is visible to the security team. And so for all of our storage customers, you end up with a piece of software that you can leverage to protect the data, but ultimately you need the incident response team to become aware of what's happening at the data layer, because they're staffed typically 7 by 24 hour. B, they have control of SIM and SOAR where they've got global visibility to threats to the corporation. So we've got, you know, spam filters, we've got endpoint, we've got intrusion detection. They have visibility to that. They need the data layer input so they can make good decisions on what threats may exist and take the appropriate actions. So when we talk about actions, what are actions that we take with our software today? So we can block a user, we can generate snapshots. Well, we do that when we detect a threat to data, but what other use cases make sense where taking actions would be beneficial to protecting data? Because remember, that's the target of all cyber incidents. So I'll use one of my favorite examples, which is a phishing alert. A phishing alert is it comes into your SOC. It looks like a user clicked on some website and typed in their password. So clearly, the appropriate action is to disable their Active Directory account. So yes, a SOAR tool can go off and do that in Active Directory or whatever your IAM platform happens to be. But that's not enough because A, the attacker may already have the credentials and they're currently logged into your storage, and disabling their account does not block them from accessing storage. So what are the correct actions? Wouldn't it be great if the incident response team could run an action that would lock that user out of the file system? Or what if they could create a proactive snapshot just in case there's an active breach underway, because they may have evidence of that in the SOC? Well, today that's not possible with other vendors, but with our solution, we can export our actions into the security layer. So now that SOC team can simply lock out a user from the file system. So what's the challenge in that? Well, A, they don't have access to the storage device. So they don't even know where they exist. They don't know how to log into it. B, typically you wouldn't be giving your security team administrative access to all of your storage devices. And C, you have to understand the permissions. I need to understand what data this user has access to. And it may not be on one storage device, it may be on multiple. So the reality is something needs to assist the SOC in order to identify the user's permissions, identify where they have access, and mitigate that risk. We can now give that power through our integrations. And here's a subset. We've got Palo Alto, Splunk, Swimlane. We can now allow those actions to be run within the tools that the security team uses, and we do not need to modify the workflows, and we don't need to teach the security team on how to execute commands on a storage device or even how to log into it. They just run a playbook like they would any other tool, and they can execute that seamlessly. And I realize some of these are going into the webinar chat, so I'll take a look over here. Any plans to protect other storage devices like Dell PowerMax? Well, being a very close Dell partner, we of course look for opportunities to expand our value prop into the entire Dell ecosystem. And so we have recently added support for PowerStore. We have support for PowerScale and ObjectScale. So certainly we always look at opportunities to extend our capabilities so that we can protect the entire Dell storage ecosystem. But yeah, we do look for those opportunities. And if you have customers, we'd love to hear about the use cases for any Dell storage product. So unified protection, accelerating the response. Incident response these days is about automation and accelerating the response time. And if you've been opportunistically able to log into a SIM or a SOAR platform, these days they're adding all kinds of event correlation capabilities and analysis. But you still have to make the decision to act. And by us feeding in the data layer, we're now going to expand the decision-making that's possible if we're feeding in threat detection or threat intelligence from the storage layer. This is how we view the problem statement of a cyber incident. It's broken down into three areas. We've got before, during, and after. And ultimately, the goal here is what can we do before an incident to mitigate the damage from a cyber incident? What can we do during that incident to protect data? What can we do after to recover and do the forensics necessary to make sure this never happens again. So this is our life cycle approach. And the problem statement shifts slightly depending on where you are in the incident, and the integrations also change. So if we take a look at before is what we call the data attack surface. And the data attack surface, so the attack surface is your data. But the true attack surface, to attack data, you need a host, you need a user identity, and then you need permissions to the data. You need those three things in order to compromise data. So we have a solution that discovers the data attack surface. But the data attack surface is more than just the user, the identity, and the shares or the exports. It is data sensitivity. So not all data is created equal. So we need to know where the PII data is stored. This is or any sensitive information, financial data, or GDPR protected data. We need to understand where the sensitive data lives. We need to correlate who's using it, how often they use it, and is their behavior normal or abnormal? And then we need to prioritize where your risks are and map it out. So we need to map out the attack surface, and we need to help you reduce it through data overexposure assessments. So can we tell you that, hey, this data is overexposed and there's sensitive data here on this share? We also need to help you better understand the hosts that are consuming your storage. So what if we could tell you that this machine has a long list of vulnerabilities because we've integrated with your vulnerability management system? Or what if we integrated with the endpoint software and got the list of vulnerabilities right off the endpoint software? And we combined that with our knowledge of the data, the sensitivity, and the user behavior, and we gave you a precise, prioritized list of where your highest risk to your data lives. And then you could go off and remediate that risk, reduce your exposure, and hopefully prevent the attack and mitigate a blast radius. Blast radius being, if there is a cyber incident, you want it contained to as little of the file system or the object store as possible. During, well, now we've hit the point where all the preventative technology that you had is now not of much use. You're now dealing with an active attack against your file system or your object storage. And now the problem shifts to, well, I need detection, and I need really, really fast detection. And so what I mean by fast, I mean seconds, not minutes, hours. I can't wait for my backup window for my backup software to tell me I have a problem. I need real-time, seconds-based detection of anomalous user behavior. Then I need the ability to stop that attack. And I also need the ability to help recover data. And I need to know that this problem is happening in real time. So I need real-time integration with my EDR, SOAR, and SOC. This is what we offer today with our market-leading Data Security Edition and Essentials products, are focused on that real-time capability and that recovery capability. When we move over into recovery, of course, every incident has a during, and then it's over. And now you're faced with recovery. So what are the most key aspects of this phase of an incident? Well, you want to have known good recovery points, verified clean data. The best way to do that, the gold standard, is an air-gapped copy of your data. There's no better way to be recovering large-scale data unless you know it's been offline and never exposed to the network. That's the number one way. Do we offer a solution that can recover the data from immutable snapshots? Yes, that's built into the core offering. Do we have visibility to the user's activity during the attack and 6 months, 1 year, or 2 years before the attack? Yes, we have the whole lineage of all data access. That's necessary for data-centric forensics. If you don't know how your data was attacked, or how the attacker got in, or which user was the first user to be compromised, if you can't piece that back together, you have very low probability of preventing that in the future. So we combine all these key capabilities and offer a best-in-class recovery solution, and then the gold standard is that air gap. Air gap, I should point out, these days is a business continuity investment, because the minimum viable business approach to recovery is that, hey, it's going to take some time for my cyber incident in production to be cleaned up, I don't have the time to wait for all my AD, DNS, and all the consultants that come in, and the insurance company that comes in with your cyber policy to help you recover. I don't have the time for that to complete. I need to operate my business. So an air gap copy is how you bootstrap that minimum viable business capable solution. And many of our customers look at that sort of clean room concept built around that air gap solution. So these are the three phases. The integrations and the requirements as to which vendors we integrate with depends on which phase of the incident. And we've got 60 plus integrations. So we've got you covered, before, during, and after. So what's the future of integrated storage aware security with existing security tools? And, we're looking at something called cyber mesh defense. So if we could mesh together all of your security tools and move away from manual human-driven workflows, what would that look like? And so we're going to give you a bit of a peek here in a second as to what the future would look like if we had an AI-driven threat hunting that combined my endpoint and my data security into a single data control plane that allowed me to leverage all of my security tools, coordinate all the actions, discover threats, enforce actions, and I could do that in seconds versus hours. What if I could just have this all work magically for me? So when we looked at the future of integrations, where we're integrating with ServiceNow or Splunk, emerging technology is the idea that AI agents can reason over a security control plane and combine information from various systems. Now, what I'm talking about here is a proof of concept. We have many proof of concepts of future technologies happening at Superna, and this is sort of heading down the path of what would the future look like if we could combine endpoint, IDS, IPS, any silo of security information that could be used to combine that with a data first security strategy and reason across it and empower an automated solution that can simply combine, evaluate the threat, promote the action plan to address that threat, and then execute against that threat, and then summarize the reasons why it did what it did. So integrations leads us down this path into AI, and AI, for those that have looked into it, there's something called Memory Context Protocol, MCP for short. This is a way for AI to gain access to tools that it can leverage to accomplish a task. And so we built out a prototype and wanted to share that, but we'll go look at some of the questions that are coming in first for a second. So pure storage, file, and object. So the product on our website, the Data Security Essentials offering does support pure storage, file, and object. So that's available now. If you go to our website, it won't go there now, but there is a module that's available that covers off pure storage. So what would it look like if we connected all the dots between all these different systems? And I'll just come back to these days, security tools all fire some sort of an alert. It goes into a SIM. There's lots of processing that happens here, and there's correlation that happens here. And then these tools generate an incident. That incident is usually where a person gets involved, and then they start doing an investigation on that incident, and they collect artifacts being discrete bits of information that lead you to a conclusion. You look at all of the artifacts in that incident that the SIM helped you generate, and you would then come up with an action plan, which is where most of the time you've got SOAR capabilities built into your SIM, or maybe you have a separate SOAR product. But now you're starting to work through the actual incident response process where you've got an incident, you maybe came from endpoint, you've got information from intrusion detection, and you've got all this evidence, and then you come up with a game plan on how you might want to respond to that. And that's usually executed through a playbook. And a playbook would be something manual that you would run in these tools. It would execute, it would tell you if it was successful or not. And then you might run multiple playbooks, right? So I might run a playbook to disable a user's Active Directory account. I might run a second playbook to isolate the machine from the network using the endpoint playbook. I might run another playbook to look at any DLP risks, where if I'm worried about data exfiltration, then I run yet another playbook. So all of these things are manual, and it all depends on the SIM having enough information in order to act on that information, and then a person to make a decision on that incident. So if we have a data security control plane that's performing discovery, enforcement, and recovery intelligence, and it makes it available to each of these systems, then we haven't really materially improved the workflow. The workflow still requires a person in each of these different systems to act. We make the security information available. We leverage some of that information, so bidirectional integrations where we pull this data in some cases, to augment our view of the world at the data layer. But what we're missing in this equation is a reasoning layer that can join all the data sets from these various systems, including the data layer intelligence, and then take some sort of action. This is that reasoning engine. This is what we're going to demonstrate shortly as a proof of concept, is the ability to take a data attack surface, risk validation engine. So this is the idea that we can look up an endpoint and find risks about that endpoint. Then we want to have some execution capabilities. We want to be able to execute commands autonomously. And then we want to do correlation of information between endpoint and storage. And I'm just using endpoint for this example, and storage for this proof of concept. And we're going to demonstrate this idea that if we mesh together a bunch of tools, then we can automate this. And we're going to, just to set this up, because the demo itself is actually a command prompt. So of course it's not the coolest thing to show, but I'll get to that in a second. So what we're going to demonstrate is we've got a data attack surface built in our DASM technology. We're using Claude for those that aren't familiar. So Anthropic, the company, Claude is like ChatGPT. It is a command prompt based reasoning engine. And so we can use this like a chatbot, but we're going to use it to do reasoning across an attack surface. And we're going to use CrowdStrike. So we've got CrowdStrike set up. This is our production CrowdStrike instance. And we've got what's called an MCP gateway. So it's a memory context protocol gateway. It exposes all of our CrowdStrike data and tools. When I say tools, that's the term used in MCP. The tools are describing, here's what data is available in CrowdStrike. Here's what actions are possible to gain access to this data. And then we've done the same thing with a prototype around our data attack surface technology. We've got an MCP gateway. Project name was called Data Fortress internally. And so that will allow us to expose what our attack surface looks like. It'll expose, in our case, tools that let you extract that data from our tool. But more importantly, in this proof of concept, we've given our MCP gateway the ability to act. So that means it can lock out a user, it can create snapshots. The CrowdStrike MCP does not allow any action. So we will present a use case to reasoning engine, which is Claude in this example, and we will ask it to use its tools, and it will autonomously figure out how to combine CrowdStrike and our data exposure to meet the objective that I'm going to present to it. So this is the prompt. So we have a SOC incident, and this is a simulated user in this example. And this is an incident that came into the SOC. And so we want to basically investigate. So we're suspicious of something going on. And this is the prompt that we're basically going to provide AI. And AI has a bunch of tools connected to it. So I'm just going to switch to that. This is a Claude Code terminal. And we've got CrowdStrike connected and our Data Fortress MCP server prototype running here. And so if I go into CrowdStrike for a second, I can say view tools. There's a lot of them. This is basically exposing, hey, there's a bunch of data in CrowdStrike, and there's lots of it here. Each of these different tools exposes to AI specifically how it can use that. So I'll go into the Data Fortress one here. I go view tools, and it basically tells the AI how, what data exists, what does it look like, and what sorts of information can it extract, and what actions are feasible through this gateway. So let me get out of there, and hopefully you can see all this. But what I'm going to do is I'm going to take that text, and I'm going to ask, imagine that I'm in the SOC, and this was, an AI that was going to assist me. And I simply just paste that prompt here saying, hey, this is a security incident. This is what I know so far. I need you to go investigate this. And I've, of course, given you some input as to what I care about. So other than that input, it built a plan on what it's going to do. And it's using the tools that's been exposed to on its own. Like it's figuring out which tool it needs to do what it needs to do. So it's now looking for that user across all the tools it's been given. So it's doing that. It's getting data back. It's now looking at that host in CrowdStrike. Say, well, what can I learn about that host in CrowdStrike? So let me go get vulnerabilities. Let me understand if there's any anomalous behavior on that machine. So it's off doing that. So it's talking to CrowdStrike. And as it gets data back, it's then reasoning across it. So it's looking at the data, joining it, and extracting what it thinks is the most relevant information based on the prompt I gave it. So it now needs to understand, okay, well, what data does this user have access to? Let me go find out what data it has access to. And actually, it knows, hey, I'm concerned about PII risk, so I don't want someone stealing any PII data. So it's going to go identify not only just a bunch of SMB shares, it's actually going to figure out the ones that have high amounts of PII on them, and that's coming out of the data attack surface engine. Now, it's already decided that it's meant to take actions. You'll see here, execute protective actions. So it wants to lock out the user and snapshot it and isolate the host, meaning isolate the host through CrowdStrike. And I'll come back down. So here are some things. It's done some analysis. It's realized the score of that user is high. It's a high threat risk. That user does access PII data, and that user has access to 11 SMB shares. All of this was dynamically discovered. It understands the overexposure ratio. It understands in the last 24 hours, there's been recent activity that is anomalous. So again, that came from our attack surface. It's identified authentication failures for that user. It's found the machine in CrowdStrike. What domain. So now it's starting to look for, ransomware specific behaviors. It's checking for lateral movement. Again, it can combine data from the attack surface and CrowdStrike. It's identified CVEs, that's coming from CrowdStrike. It's found that that's probably not good, actively exploited in the wild. Here's specific share names. They're at risk. This is flagged by the attack surface as being high risk. So it understands that this user has access to these shares. These are important shares. So keep going down. So it's now summarizing its findings. Full list of shares. Remember, that was just a single prompt, right? It's reasoned out everything that you're seeing here. So it's also figured out that CrowdStrike doesn't actually expose the isolate host capability through MCP. So it realizes that that's not good. That means you're going to need to log into CrowdStrike and you're going to need to use the contain host action. So it's helping the operator take those next steps. And that this is a high risk right here. And it's used the MCP gateway from Superna to go and lock the user out. It's confirmed that was done. It's snapshotted the shares. It's flagging the fact that, hey, I can't lock out the host from the network, so you need to go do that manually. And it's flagging that there is an exploitation potential here from this CVE, and then the action plan at the end. This was completely autonomous. I just pasted the prompt in, gave it access to some tools that self-described what the tools could do behind those tools. And clearly, if I exposed more tools, like my endpoint is obvious, intrusion detection, my spam gateway, if I started combining and just feeding more tools in, this is the future of threat hunting and incident response, is fully autonomous. Now, this was all happening on my laptop through those MCP gateways. The information that you saw being queried, it goes off as tokens into our Anthropic account. That's where it does the reasoning in a temporary session. So that information is temporarily held in memory while it's executing the threat hunting exercise. And clearly this did this at a speed that no person could possibly replicate. And so we have integrations today, but the future is cyber mesh. It's combining all your tools into a singular response. And the data layer is pivotal, because if you can't expose the who, the data access permissions, the sensitivity of the data, imagine that I ran the same demo and it had no ability to understand the threat of the data itself. It would only be able to tell you that, well, there's a CB on that host and maybe you should isolate it. It wouldn't understand the blast radius. It wouldn't understand the user's behavior. It wouldn't understand the sensitivity of the data, would not identify additional areas where your data is now exposed. Again, data. It's all about protecting data and combining the data attack surface information and our actions that we can take with our security product, deliver a completely automated solution. So this is what the future looks like, and we're excited to kind of share this proof of concept and how we see the future unfolding.
Andrew, I just wanted to say really quick, you were the one that is able to release the polls, and I know we're coming up on time, but if we wanted to spend a couple extra minutes, we could run this real quick.
There's one. Yeah, we appreciate the polls. Launch the next one. We're really trying to, build better solutions for you, and to do that, we want to know who our customer is, and is it the storage team, the security team, or both? We'd love to optimize our investment around what is the best possible way to help you solve incident response. And it's fantastic. Thanks for the results. And then I'm just going to launch the next one. Permissions management, at the end of the day, this is it's the bane of a file system, is decade-old ACLs that you inherit as an administrator. So I'm going to end that one. Thank you for that. We get asked about data classification a lot and content security, right? Sometimes you are not responsible for that. If it's you managing the storage infrastructure, who owns that? And then we've seen this land in various teams as to who owns this, because they end up having to integrate with your storage. And this is a key area that we want to understand your pain points. And look at that. No clear owners almost winning, catching up there. This is great. We love this sort of feedback. And one last one is access to security tools. We build solutions. We want to make sure they're optimized for the person that's going to be using them. And so there's definitely things we can do in the product. Okay, fantastic. Then we appreciate the feedback. This really does help us improve the product. If you heard something today and thought, hey, I'd love a deep dive on that, just reach out to us. Be more than happy to jump on a call. Would love to hear what people think about cyber mesh and the future of donating your data security to your security team to better protect your data, and any feedback you had on today. And we'd be happy to talk about integrations. We've got a whole integration program. We can help you get our tools, technologies integrated. That's a part of the support offering. If you're existing customers, just open up a support case. We'd be happy to walk you through all the different integration options and get them in place for you. So that's no extra cost. That's built right into our support offering. Okay, great. Glad we got those in. Yeah, it was awesome seeing so many people join and hang in to the very end. That's great. And love the feedback.
Perfect. Yeah. Okay. Well, thank you everyone
Great.
for joining.
Thank you, and have a great day.